Okay, folks, this is all about perimeter. Now, quite often I've noticed a lot of you confuse perimeter with area. Now, you mustn't get these two concepts confused. They are very, very different things. I'm going to give you a very, very simple example of what each one is, but we're going to be dealing with perimeter mostly for this. So if I have a square, um, there's a little square there, and it has equal sides because it's a square, and say the sides are 3 centimeters. Then the perimeter is the distance that we have when we travel around. So it's like walking around the block, essentially. So it would be 3 plus 3 plus 3 plus 3. So we would have 12 centimeters, or 4 times 3. And it would be perimeter is equal to 12 centimeters. Pretty simple. Biggest problem is people get those concepts confused. If I wanted the area of this, and we'll be doing area a little bit later on, we would just say one side times the other, length times breadth, okay? And in this case, the length and the breadth are the same because it's a square, so it would be equal to 3 times 3, which equals 9 centimeters. But this time, to make sure that we understand it isn't a perimeter, we say 9 centimeters squared. Your areas are always going to be to the power of 2 centimeters squared. Okay, so it's 9 centimeters squared. When you see centimeters squared, you know it is an area. When you see just centimeters by itself, it is a length. Okay, that's the way we tell the difference. So that is how we're going to tell the difference between our length and our area. One is just centimeters, the other one is centimeters squared, okay? When we get looking at a perimeter, perimeter is just the distance around a shape, okay? It's as simple as that. So when you see perimeter, think about going for a walk around the block. Okay, let's look at some questions that might be a little bit more complicated. Finding perimeters. Okay, I'm going to use the example in the book. It's a good one. And basically, or actually, we'll use one of the examples from exercise 3A. So you're going to be practicing exercises in 3A, but we're going to grab one of the examples. So in this case, we have a reasonably complex shape that looks something like this. And this says 3 centimeters. Then we have the same 2 strokes there, and then we have 10 centimeters. So whenever you're trying to solve a problem like this, what you need to do is you need to first of all say, they're saying find the perimeter. Okay, so people quite often look at a problem like this and they just go, well, how am I going to find that? There's a side missing here, there's nothing written here, there's nothing written here. How am I going to calculate the perimeter of this shape? Because I'm missing information that I need. I know how to get a perimeter, but I don't know how to find those missing things. Well, whenever you see this type of stroke on the lines, if they have the same number of dashes, it means it's the same distance. So straight away, I can write 3 centimeters there. So now I've got one of the unknown sides that I didn't have. Then what you need to do is you need to turn around and say, well, I don't know the distance from here to here. That's a bit of a question mark. And I don't know this distance here as well. That's a question mark. So I'm suddenly going, well, how am I going to work out those two added together? Well, I know that if I was to walk from here to here and then walk straight across to here, it's 10 centimeters because I've already got that distance there. So that distance plus that distance is going to be another 10 centimeters. Okay, I don't need to know individually what these are. I just need to know what they are added together. So that's going to be 10 centimeters. And then I need to just work out what this distance is here. Now I know if I walk from here to here, I've gone 3 centimeters, and then I need to get from here to here. Now I don't, obviously I think I don't know this distance, but it's the same distance as over here because these are all 90 degrees. So if this was a rectangle, if this is 3 centimeters, then this is going to be 3 centimeters. So I know straight away that the distance across here is going to be 6 centimeters because it's that distance plus that distance. And I know conversely that if I add this distance and this distance together, it's going to be equal to 10 centimeters. So knowing all of that, I just have to start on one side and work my way around. So I'm going to say this side is going to be 10 centimeters. And to that I'm going to add 3 centimeters, this side here. And then I'm going to add another 3 centimeters. I'm going to add these two sides here, because that's going to be another 10 centimeters. And then finally, coming back up here, I'm going to have another 6 centimeters. So adding all of that up, we've got the 2 10s, this gives us 20. We've got the 2 3s here, plus a 6 gives us 12. So all up, it's going to be 32 centimeters. So the perimeter is going to equal 32 centimeters. And it's as simple as that. Let's do another example, just to make sure we understand that concept of finding the unknown side, because that's the hardest thing about these problems. Once you know perimeter is the distance around a shape, it's just working out how to find that unknown side. So let's do this one. This is a little bit, well, it's a similar sort of shape, but it's just turned over a little bit. So let's do that. We know that that is 2 centimeters. So straight away I'm going to look for something that has the same number of strokes. I haven't drawn this to scale, by the way, and sometimes they'll do that in an exam to try and trick you. So be careful of that. If it has 2 strokes and 2 strokes, it is the same distance. And then up here we have 1 centimeter for this little bit here, and here we have 4 centimeters. So we do not know 2 sides. We have this side here. On this side, it is a big question mark. And we have this side here, also a big question mark. We know that perimeter is the distance around a shape, but we need to work out how to find the unknown sides. Now, I know that this side here, which I don't know where the pencil is the same as walking from here to here to here. Okay, and I know that this is 2 centimeters, and I also know that this is 2 centimeters, although I've drawn it a bit too long, because those two have the same number of dashes on them. That's a double dash, and that's a double dash. So I can write in my unknown here, 2 centimeters. Then I need to say, well, what about this distance here? If I walk from here to here, it's 2 centimeters, because I can see it's a double dash. And if I walk from here to here, okay, it's also the same as this side here, because this little box here is a rectangle. Okay, sometimes it might help to draw that in. Draw that line in and say, okay, well, if I know that side and I'm trying to work out this distance, because this whole distance is that plus that, it's going to be another 2 centimeters. So this whole side here is that plus that. And we know this and this are the same, so it's 2 centimeters there. So we know this whole length here, because this is also one big rectangle. Okay, this is a big rectangle, this is a big rectangle. So this distance is that plus that, which is 2 centimeters, plus 2 centimeters is going to give us 4 centimeters. Okay, then we just need to say to ourselves, well, what's this distance across here? Well, we know it's that plus that. We know that's 4 centimeters, and we know that this, because we come up here, is going to be 1 centimeter. 4 centimeters plus 1 centimeter is going to be 5 centimeters. So we now know all the distances on this shape. So then you need to be systematic, and you might even help to draw a little asterisk here to say, I'm starting at that side if it's a really complex shape. And we're going to say it's 1 centimeter plus 2 centimeters plus 4 centimeters plus 2 centimeters, I'm going to run out of room here, plus the 5 centimeters plus the 4 centimeters. And then I have to try and do mathematics in my head, and I'm not very good at that. So that's 1 plus 2 is 3, plus 4 is 7, plus 2 is 9, plus 5 is 14, plus 4 is 18 centimeters. So the distance around this shape is 18 centimeters. Perimeter, okay, equals 18 centimeters. So that is how you find unknown sides. Just remember, draw your rectangles if you need to. Remember that if it has the same number of dashes, it's the same length, and you make sure you write in all your unknown sides. They will never give you a problem where you can't find a side. Okay, I am going to do one more question because there's questions involving triangles that you might want to get your head around. So we'll do one more question, and that'll be it for perimeters. Okay, so let's just get this done. Okay, perimeter of, let's do the example of a triangle with an unknown side. Okay, so we're going to go like this. Okay, we're going to go and we're going to say the base is 3 centimeters and this is 5 centimeters. And we're going to say, well, what's the perimeter of this triangle? Straight away, looking for the dashes. The only side we don't know is this one, okay? But it's got the same number of dashes as this one. We know that's 5 centimeters. So we write in 5 centimeters, and then we just add up 5 plus 3 is 13 centimeters. So perimeter, I'm just going to say P equals 13 centimeters. Really simple. You might sometimes get a variation of this question where they won't, if they're going to be really nasty to you, they won't give you any of this. They might just say that's this is 30 degrees and this is 30 degrees. And you'll say, well, if I know that's 3 centimeters, and they'll have to give you one measurement. So they might say this is 5 centimeters, but you don't know what this one is. But there's no dashes on this one. So how do you know this one is going to be the same length as this one? Well, what they'll do is, what you need to remember is that the base angles of an isosceles triangle are equal. So the two sides are equal and the base angles are equal. That's going to be a really nasty thing to do to you, but you never know, they might do it. So it might be an idea just to remember that. Anyway, that is how to find perimeter. I'm hoping that's been helpful, but the only way you're going to really get good at this is to practice. So I would go into exercise 3A and do all the questions that you can and make sure that you are thoroughly comfortable with the concept of perimeter. Bye.